everyone. Myself Dikshit B. I am currently studying Sri Venkateswara College of Engineering, 3rd SEM, Information Science and Engineering. Now we discuss about the subject data structures. But now we discuss about introduction static hashing. Introduction to static hashing. Static hashing is a technique used in computer science to efficiently store and retrieve data in a fixed size hash table. It involves dividing the hash table into a fixed number of buckets or slots, with each bucket capable of holding a certain number of elements. Static hashing is suitable for applications where the size of the data is set known as advanced and does not change frequently. Basic concepts of static hashing. The key idea behind the static hashing is using a hash function to determine which bucket in hash the hash table is given data item should be stored in. Each bucket is associated with a specific range of hash values, and hash functions ensure that data items are evenly distributed among the buckets. When searching for a specific data item, the hash function is used to quickly locate the appropriate bucket for retrieval. Static hashing versus dynamic hashing. Plain text, hash function, and hash text. And we can see this in this figure: static hashing versus dynamic hashing. Hash function in static hashing. The hash function takes the key of a data items as input and computes a hash value, which is used to determine a bucket in which the item should be stored. A good hash function should produce evenly distributed hash values to minimize collisions and ensure efficient retrieval of data. Common hash functions include division hashing, multiplication hashing, and folding hashing. Collision resolution in static hashing. Collisions occur when two or more data items map to the same bucket in the hash table. Collision resolution techniques such as chaining or open addressing are used to handle collisions and store multiple data items in the same bucket. Chaining involves maintaining a linked list of data items in each bucket, while opening an address involves finding an alternative empty bucket for a colliding item. We can see the hash table in this figure. Key 1, key 2, key 3, key 4 equals to index and as well as values. Advantages of static hashing. Static hashing provides fast insertion, deletion, and retrieval of data items with constant time complexity on average. It is suitable for applications with a fixed size data set and known distribution of key values. Static hashing is easy to implement and offers a good performance for a wide range of applications. Disadvantages of static hashing. Static hashing lead a waste specific if the data is set is smaller than expected. Resizing the hash table in a static hashing can be challenging and may require rehash all data items. Collisions can impact the performance of a static hashing, especially in the hash functions is not well designed. Applications of hashing. Static hashing. Static hashing is commonly used in database management systems to index and retrieve records efficiently. It is also used in the file systems to map file names to physical disk locations for a quick access. Static hashing can be applied in networking for routing and addressing resolution purposes. Real-world examples of static hashing. The extensible hashing algorithm is a variation of static hashing used in database systems like SQLite to manage indexes efficiently. The cuckoo hash technique is another example for static hashing used in the high-performance hash tables. Static hashing is utilized in programming languages like Java and C++ for implementing hash maps and hash sets. In this figure, we can see the hashing algorithm, plain text, as well as we see in the previous example. Best practices for implementing static hashing. Choose an appropriate hash function that produces evenly distributed hash values to minimize collisions. Monitor the load factor of the hash table and consider resizing or rehashing if it becomes too high. Test the performance of the static hashing implementation with different data sets and workloads to fine-tune the design. In conclusion, static hashing is a powerful technique for efficiently storing and retrieving data in a fixed size hash table. By understanding the basic concepts, advantages, and challenges of static hashing, developers can design robust and efficient data structures. With proper implementation and optimization, static hashing can be valuable tool in various applications requiring fast data access and retrieval. Thank you for watching my video. Please like, share and subscribe. Thank you.